All right. Okay. I don't want to delay. Let's get started. So yesterday we talked about 3 properties. They were the product rule of logarithms, and then we had the quotient rule, which let us split up a fraction into subtraction. And then we had the power rule. Okay. So these are just some examples of using those properties. So if we want to expand this logarithm out, what is the first thing we should do? Any ideas? First move.
Move the power.
Yeah.
Use the power rule.
We need to bring that power down first, okay? So we're going to bring this in the front, and this is going to be 3/2 times log base 8 of this fraction. Okay. Now, once that power is off there, we are free to do the quotient rule. See, before we take that power to the front, before we parachute it to the front, we really can't operate with that quotient rule because it doesn't tell us anything if the quotient is raised to a power. Okay, so now this is the same as saying 3/2 times log base 8 of x minus 1 minus log base 8 of a squared. Okay.
Wait, Professor, and how about if we just wrote it the 3/2 between each of them? So like I wrote it before the log 8 x minus 1, then minus 3/2 log 8 8 to the second power.
Mm-hmm. Yes, that's good. I'm going to distribute it. I was just going to wait till the end to do that.
Oh.
Because now that we have this, what rule can we use next? There's one more rule.
Quotient rule again? Or power rule? Sorry.
Power rule. Okay, that a squared. So we should end up with the same thing, Abir. This is minus 2 log base a 8 of a. Okay, and then it's all multiplied. Now when we distribute, this is 3/2 log base 8 of x minus 1. What is 3/2 times 2? Right?
Would it be 6/4 or 6 or just 3?
Multiply straight across, and it's 6/2 or 3. Okay, yes. So you just want to make sure you simplify that part, and this is 3/2 log base 8 of x minus 1 minus 3 times log base 8 of a, and that's the final one. Okay. Do I know anything about subtraction inside the log input area? Like, is there anything I can do with this? No. Okay. I was trying to test you guys. I don't know anything about subtraction inside of log. All I know is that I can take when it's a fraction in there and break it up into subtraction. Or I can take the subtraction and bring it together as a fraction. But there's nothing I can do with that. So I just want to make sure you guys understand that that's it. The end is here. There's nothing more to do. Any questions? All right, now this one, I kind of threw 3 logs at you, but it's okay. We're going to do it, but we're going to do it left to right, okay? But first, the opposite move is to bring your exponents up. So in the first one, we had to bring the exponent down. Now we want to put that exponent back up. So this should be log base 2 of x to the 1/2 plus log base 2 of y to the 3rd minus log base 2 of z to the 5th. Okay. What is the rule if I have plus? We bring them together using what?
Multiplication.
Product.
Multiplication. Yep. And then I can do the quotient. Log base 2 It'll be x to the 1/2 y to the 3rd over z to the 5th. Now that's fine, but x to the 1/2 is also, just realize that that is a root. So if you wanted to, you could write it like this. These are same. Any questions? All right. Okay. A couple of things I wanted to say. I got through most of the quizzes yesterday. Only the ones that are left are the ones that people sent me an email that I had to attach because I have to, I think, switch to my laptop. I don't know. It's not pulling up on my iPad. You guys have to do sign charts, okay? Some people are trying to answer the questions and miraculously getting the right answer, but you're not doing a sign chart. Some people did like a true false kind of approach, which works, but then you have to show me all the work. You can't just say, oh, this will make it true or this number will make it false. No, you have to like calculate it out and show me that it makes it true or false. Also, if you answer the problem and you don't do a sign chart, it's automatically deduction. I deduct points because that's the way it's graded on your final exam. So you have to learn how to do sign charts. So if you're still unsure about it, don't procrastinate. It just does not get easier. You need to come to office hours and do extra work on that. Okay. It's not going away. And you do have to use them in pre-calc a lot too. So yeah, don't avoid. All right. There's my little mini lecture within a lecture. Are there any questions about that? So make sure you look at the comments on the quiz, and I am going to post the answer keys. I got to post a lot of answer keys, as a matter of fact. All right. Now, section 9.5, I'm just going to say a couple words about this. It's about natural logarithm function. Okay, so the natural log function f of x is equal to ln of x is it's special. So the only thing that makes it special is the log function with base e. Okay, so if you have something that's like this, it's called log base e of x. We don't write it like that. We naturally write it as natural log of x, and that's the notation. It's just understood that this is a logarithm with base e. So what is e? It's just a constant similar to pi. Let me put that in parentheses. Similar to pi because it has a decimal that never ends and never repeats. Okay, is a constant. But e is approximately, its approximation is 2.71. It is an irrational number that never ends and never repeats, which means that's what it means to be irrational. Okay, so this goes on forever and ever. If you wanted to understand it more thoroughly, you would need to look up the golden ratio. Okay, it's defined using this golden ratio. But for our purposes, it's just when you have log base e, it's called natural log of x. It's just a notation. And once you go up to like pre-calc and calc, we really only talk about ln of x. We don't get away from this log base of other functions because it's so It's so widely used in calculus, natural log of x, okay? Other than that, I'm not going to do too much more with that. I just want you to be aware. So, oh, you know what? I need to do another example from, before I do solving log equations, we need to do another example from yesterday. Okay, so this is technically 9.4. I want to do another one of these because we're kind of rushed at the end, using the approximate values okay. Log base 7 of 6 equals 0.9. And log base 7 of 18, go away. Log base 7 of 18 is 1.5. I want to find, okay, so here's A, log base 7 of 3. B is log base 7 of square root of 42. And then C is log base 7 of 1 over 36. Okay. So the first thing I want to note is that you cannot change 3 square root of 42 or 1 over 36. You cannot add numbers in or subtract numbers out or just multiply by something. The only thing you have in your bag of tools here is to rewrite the number, okay? So we can rewrite 3 square root of 42, 1 over 36, using arithmetic or powers, but we cannot change them. Okay, so let's start with this one, log base 7 of 3. I want to rewrite 3 using what I know about these other inputs here, like 6 and 18. How can I rewrite 3 using those two numbers?
You could do 18 divided by 6.
Yeah, very good. So that does not change my input at all. If I divide that, I still get 3, okay? So I can't do 3 times 6. Like you couldn't think like, oh, let me make this 18 because then I can work with it. You cannot add or multiply a number into it. You can only rewrite it, okay? So now once I have this, I can use my quotient property. And I have log base 7 of 18 minus log base 7 of 6. And now that it's broken apart, it's expanded out, I can just plug in those numbers, right? So this is 1.5 minus 0.6, which is 15 minus 6 is 9, and it's going to be 0.9. Any questions?
6 was 0.9.
Yeah, 0.9, 0.9.
No,
You put for log 6, you put
0.9.
0.6. It's 0.9.
I switched these. Thank you. Okay. Good. Now, here's a warning. Show your steps. Okay. So students get really, you guys are quick. You got those quick little 18-year-old minds. So a lot of students want to jump from here to here. And they'll just give me the decimal. You're going to lose points, first of all, because I have to see that you use the properties. And secondly, if your decimal that you write down is wrong in any way, you get 0 credit. At least if you like try this and then do what I just did, wrote down the wrong decimal, I'm probably going to give you your points, or at least, you get nicked just a little bit. But if you had not done any of that and just wrote down 0.9, I would have given you a 0 on that problem. Okay. So I cannot know your mind if you don't show me the property you're using. So show your properties. All right. So this one, any ideas on what we can do with 42? What's the most obvious thing to do with 42?
Square root it.
I want to use 6 and 18, or just 6 or just 18. You don't have to always use both of them.
Could you use 6 and 7?
Yeah, let's try that. And it should be kind of like little light bulb go off because you have log base 7. That's going to make some stuff nice. So I'm going to write this as the square root of 6 times 7. But let's take it a step even further and write this root as an exponent. Okay, so when you have the root, you want to write that as an exponent because I have a rule that allows me to work with that. That allows me to parachute this exponent down in front. And now I can use my product rule. Okay, so we're going to break these apart. This is 1/2 times the quantity, log base 7 of 6, plus log base 7 of 7. And this is 1/2 times log base 7 of 6, let me double check, is 0.9. So I don't write the wrong thing down. Plus, and then log base 7 of 7 is 1. Yeah. Okay, so anytime you get that to happen, that's helpful. And then this is 1/2 times 1.9. Now, the easiest way to do this is just make everything a decimal. So it's 0.5 times 1.9. And 5 times 1 plus 4 is 9. I have 2 places. This is 0.95. Okay, any questions on that? All right, why don't you guys try the third one if you haven't started it already? Let me give you like a minute to work it out. Okay, would anybody like to volunteer what they tried, what they did? Any ideas?
I did the log 7 of 1 and then minus log 7 of 6 squared, or 2 log 7 6, I guess.
All right, let me just show all the steps. So first you break it out into the subtraction, and then you're right, we can see that this is going to be log base 7 of 6 squared, and we like 6 because we know something about 6. And then you bring your exponent down. How many people did it this way? This approach. Give me a thumbs up if you did it this way. 1, 2, 3, 4. Okay. All right. So then we can plug in our numbers. What's log base 7 of 1? What'd you get there, Abil?
That's as far as I got.
Okay.
Well, I know the other part, but I don't know log 7 of 1.
All right. It's the same as asking 7 to what power will give you 1?
0.
0. Okay. The power that goes on 7 is 0. So minus, and then this is 2 times 0.9, which is just really negative 1.8. Now, did anybody have another way to do it? There definitely was another approach. Because you're going to find, like, for number A and B, for part A and B, there's not too many other ways to do that. You might get a little clever, but you probably are just doing more steps than you need to. But this one, we could also have written this as log base 7 of, okay, 36 is 6 squared. But since it's 1 over, it's just a negative 2. Did anybody try this, right? 1 over 36 is 6 to the negative 2 power. Okay, and I just want to show you because this is good too, and it gives us the same thing. So this is negative 2 times 0.9, which is negative 1.8. Same thing, okay? Any questions? All right, so here's the thing, you guys, on your hand-in homework for Wednesday, there should be more of these, and you're going to get some in workshop. They look pretty easy until you try doing them, and then they're harder. So you have to get your hands dirty. All right, now we're going to do 9.6, which is solving log equations. Which we have done a little bit of, but now that we have these properties, we can do more interesting ones, okay? So here's the method to solve log equations. Okay, 1, move all of the log terms to one side of the equal sign. Obviously using arithmetic, adding and subtracting, okay. And everything else to the other side. Okay, 2, use properties to condense into one log, okay? Then you're going to use the definition of logs handwriting to get rid of the log. I can't solve it as long as it says log. And then the last thing you have to remember is if you used a log property, which almost always we're going to, you must check your answers. Right? So for number 4, here's why. Why is this important to check? Let me just show you something simple with numbers, okay? If I took something like this, log base 8 of negative 2, and I added log base 8 of negative 4. So first of all, can I put a negative number into log? No. What is the domain restriction on log functions? Hello?
It can't be less than 0 or something.
Yeah. Okay. So if you have log base a of x, x has to be greater than 0. You cannot you cannot plug in 0 or a negative number. Okay, you cannot plug those in. So these right here, this is not a real number. But look what happens when we use the property. So I have two numbers that are not real. Literally, if I try to put them on the X and Y axis, you can't. They don't go there. But if we use that nice little product property, this is going to be log base 8 of -2 times -4, which is log base 8 of 8, which says this is really 1, but that is a real number. Okay. So you're basically saying two not real numbers can add together to make a real number. This is not true. Okay. So when you use the properties, you have to realize that sometimes they can give you answers that are actually not going to work. Okay. And so in this first example, we're going to see that. Let's do example 1 here. Let's say you have log base 10, log base 10 of x equals 1 minus log base 10 of x minus 3. So, what is my first step? What must we do first?
Bring the logs to one side.
Yes, I want all the logs on one side. So the easiest way to do that is we're going to just add this log base 10 of x minus 3 to both sides. So we get log base 10 of x plus log base 10 of x minus 3 is equal to 1. All right, sweet. Now we got all our terms on one side. We want to condense this into one log with the plus in the middle. That's my product property. So this is log base 10 of x times x minus 3 is equal to 1. Any questions on that part? Now, here's where students make mistakes. They try to start solving, blah, blah, blah. You cannot do anything until you free up x times x minus 3 from the log. How? We're just going to use the definition, man. That's all. So here's my base, 10. This is the power that goes on 10. 1 is the power. Remember, log base a of x, if it's equal to y, it's the same thing as saying a to the y is x, okay? That's the property I'm using. That's the definition. So 10 to the 1 is equal to x times x minus 3. Now, once we have that, this is just a quadratic equation. We can just solve it like we normally would. So this is 10 is x squared minus 3x. Subtract 10 from both sides. And I get x squared minus 3x minus 10 is equal to 0. All right, this should be familiar territory. We got to factor this. So x and x, how does it factor?
Plus 2 minus 5.
Sounds good. And we solve these equations. So this is a 0 product property. If you have two things multiplied together, you can set them equal to 0 and they're equal to 0. So x is -2 and x is 5. So let's check. I'm going to do it on the side here. So let's take x equal to -2. I'm going to plug it into my log equation. You always go back to the original. So log base 10 of -2 plus, well, here's the thing, folks. We can stop right there. This is already dead in the water. I cannot plug a negative into my log equation. This right now is not real. So we're going to throw this out. Okay, done. It doesn't even matter. It could work in the other log. In this case, it doesn't. But even if it works in one and not the other, you still have to throw it out. You cannot plug a negative number in. All right, so let's say x is 5. Let's just check that. Log base 10 of 5. Whew, looks good. Plus log base 10 of 5 minus 3. That's also going to be good. So I end up getting inputs. Okay, and we could, you can see if you multiply those together as log base 10 of 10 is 1. I don't care so much about that part. You're looking at the domain. Okay, so this one is good. I can plug it in. Any questions? All right.
So if 5 didn't work, would we just say no solution, or?
Yeah, you would say no solution. I'm trying to think if that actually happens. I think usually at least one of them works out. Because I don't know if I can prove that to you. Have to think about it. All right, I want you guys to try this on your own. I guess they could both not work out. I have to do some research though. Okay, log base 2 of x plus 7 equals 3 plus log base 2 of x minus 7. Okay, you guys give that one a whirl. See if you can get at least to the condensed log. Let me see what you get. Okay, did you guys get this? Get the logs on one side, and then this one's a quotient, right? You should have subtraction, you bring it together as a fraction. Now, what's the next move? D'Angelo, what do you think? Oh, Abil.
2 to the third.
2 to the third. Yes, we need this 2 to the third is going to equal the stuff inside. Okay, you have to write that. All right, so here's 8. We're going to multiply both sides by x minus 7. And you get 8x minus 56 is equal to x plus 7. Ooh, so something that's nice here is this is not a quadratic. All right. I get 7x minus 56 is equal to 7. Add 56. Oops. 7x is equal to 63. And did anybody else get this? Did anybody get 9? All right, sweet. Now, before we box it in, let's check. Go back to your original. You have not this one even. I would go all the way back to your very original equation. So log base 2 of 9 plus 7, no problems there, equals 3 plus log base 2 of 9 minus 7. That's a 2. That's a 16. We're good. Okay. Any questions? Oh.
When we check, do you want us to like actually like, go through each step, or is it just enough to put it out like it is?
You mean like all the way to the end?
Yeah.
You can. The most important thing is you're just really checking for the domain, that you're not, when you plug it in, it doesn't give you anything negative.
Okay.
That's what's most important, because this will work out. We can keep going if you want. Look. Okay, this is going to be 2 to the 4th gives you 16. That's the exponent's 4. This is 3 plus 1. Okay, it does work. Sometimes they don't all work out as like nice as that though. So really your focus is the domain. Let's do this one. I want to show you one. So make sure I don't run out of time. Okay. Log base 7 of x plus, I'm sorry, this should be x plus 1 plus log base 7 of x minus 1 equals log base 7 of 8. Okay, now everything is a log term. That's okay. We still have to follow the same procedure though, get everything on one side of the equal sign. So let's get that log base 7 of 8 to the other side. We're going to subtract it. Now what happens when I subtract it from this side? What am I going to get over here? 0. Okay, that's okay. Don't lose your 0. Okay, sometimes when students get everything on one side, they lose the other side of their equal sign. It's fine, no problem. All right, now let's condense these into one. These are the product rule. So I have log base 7, and this is x plus 1 times x minus 1. And then now that I have subtraction, we can make that a quotient, right? So this is log base 7, x plus 1 times x minus 1 all over 8. Is everybody okay with that? Any questions so far? All right, now we use our definition. 0 is the power that goes on 7 that gives us what's inside. Is that okay? So sometimes students get to this place and they don't know what to do either. It's okay to have 7 to the 0 power. That's just a number that we now know is 1. Okay, so this is just 1. X plus 1 times x minus 1. That's just the difference of squares. If you multiply it out, you get x squared minus 1 over 8. Now multiply both sides by 8. And you get 8 is equal to x squared minus 1. I can add 1 to both sides, We have a different way. We can do this two different ways. You could get everything on one side and factor, or you can just realize this is x squared is equal to 9. And if I square root both sides, x is equal to 3, x is equal to -3. So -3 squared is 9 and 3 squared is 9. All right, I'm going to put the check over here. All right, so if I do log base 7 of -3 plus 1, this is already what? Log base 7 of -2. No. Okay, so again, it's not that your answer can't be negative. I want to clarify that. In this case, our negative answer didn't work, okay? But that doesn't mean that it will never work. There's actually going to be some where the negative answer works and the positive one won't, okay? It's once you plug it in, then what are you getting inside, okay? So this is not going to work. +3 is going to work. We can see if we do log base 7 of 3 plus 1, that's fine. It's going to be log base 7 of 4. And then plus log base 7 of 3 minus 1. This is log base 7 of 2. And then you have minus log base 7 of 8, which doesn't require anything. And this is good. No domain issues. So this one's going to work. Any questions? All right, let me give you guys one to do. That one's too long. I'll have you do this one. Solve log base 2 of x plus 11 equals 5 minus log base 2 of x plus 7. Give you guys like 2 minutes. Okay, I had the first 3 steps up there. Getting logs on one side, condensing to one log, and then using the definition to get rid of the log. Okay, did you guys get this quadratic? X squared plus 18x plus 45 equals 0? Hopefully. Yes? Okay. Anybody get it factored yet?
X plus 15 and X plus 3.
Yeah, very good, Christian. Okay, so then that means X plus 15 equals 0 and X plus 3 equals 0. So X is negative 15 and X is negative 3. Now this is a case where they're both negative numbers. Which one of these inputs will work and which won't? Look back at your original. If I put in negative 15, yeah, so look, we get log base 2 of negative 15 plus 11. That's log base 2 of negative 4. This is a no, okay? But negative 3 will work, okay? If I do log base 2 of negative 3 plus 7, that's okay. It comes out positive, okay? Same thing if I do, so this is equal to 5 minus log base 2 of negative 3 plus 7. Whoops, this should have been plus 11. This should have been 8 minus log base 2 of 4. So this is okay. So only negative 3 works. Any questions? Okay, I will be at office hours at 11:30. Please come, don't make me chase you. Other than that, have a good day. I'll see you